For the rest of the methods unit, I'm going to go through three more groups of things. I'm going to talk about different research tactics or designs in two videos, one talking about descriptive and correlational methods, the next talking about experiments, and then I'll talk a little bit about research ethics. So to dive in and talk about descriptive research. Obviously, as you might expect, this might have a lot to do with that first goal we talked about in the scientific method of describing what's going on. But depending on how you carry out your descriptive research and what you might observe, you can probably use it for prediction in many cases too. But descriptive research, or observational research, as we might call it as well, very broadly involves tactics and methods that involve direct observation and description of behavior. So it might be a study where someone goes out into the real world and records behavior, or a little bit more controlled of an environment. Maybe someone like this is, behind a one-way or two-way mirror, whatever it's called, watching people interact, like a focus group or a preschool class in an education school, for example, or an institute of child development, something like that. Some issues that come about with observing people is that when you observe someone, there is an effect on them. They have an awareness of being observed, and they might react in a certain way. And that is generally called reactivity, that someone's behavior is changing because they're being observed. So children, for example, might behave in one way when they're just playing with one another, but if an adult is watching them, they might change the type of play they're engaged in. So there's reactivity there. And then what you're observing might not be as useful as if they were behaving more naturalistically. Thus, this tactic where they can't see the adult observing them in their classroom. Another really important aspect of not only descriptive but any kind of research is something called external validity. When we get to experiments, we'll talk about internal validity as well, but external validity is basically the extent to which your observations or findings generalize to other types of situations or actually represent something approximating real life. So if you go out into the real world and observe people engaging in some kind of behavior, and you're not interfering with them, they don't know you're watching them, that probably has very high external validity. It's probably very realistic and probably generalizes to other types of situations in the real world. If you bring people into a laboratory to observe them, then the external validity there might be much lower because they might be behaving in a more artificial manner and not be behaving in a particularly realistic or representative way. You can get around this, of course, it's something I've already alluded to, have high external validity by engaging in naturalistic observation. So if you're doing this out in an actual school or a street corner or a market or something like that, that behavior you're observing there might be a little more externally valid or ecologically valid than if you did it in a laboratory or some other artificial type of setting. So in this type of observation, you are trying not to get involved. You're trying not to influence anyone or even generally let them know you're observing them. Because that awareness is where reactivity comes from. You don't want people to change their behavior on account of the awareness they're being observed or evaluated. A different tactic that's kind of building upon naturalistic observation in a way is something called participant observation, where you actually might become part of the group that you want to observe. So there are certain groups like cults or political organizations, political movements that perhaps they are not easily observed. They have meetings that are closed door or something like that, or they change their behavior in the presence of observers. Well, you might, in that case, want to become part of that group and become something like an actual group member, whether you actually buy into their cause or their beliefs or not, to be able to observe them acting realistically in their actual group setting. Obviously, this is a little bit ethically dubious because you're lying to people. You're taking advantage of them, and you would want to follow up afterwards to make sure people were okay with you sharing the findings, or at least anonymize them in a very purposeful way. Probably the most famous version of this is a study from a book called When Prophecy Fails by a social psychologist and some of his colleagues. The psychologist was Leon Festinger. There was a cult I believe in Chicago in the 60s, and they believed that the world was going to end in a great flood, and they needed to buy into this group. And they would not give interviews or anything, but these researchers at the time thought that they could use this as really convincing evidence that people don't always act rationally. So they joined the cult, and they observed what was going to happen this night that the flood was supposed to come. And rather than being turned away from the cult because their prophesized flood didn't come, people bought into the cult more because of something called cognitive dissonance. They wanted to keep the buy-in and the sacrifices they had made consistent with the importance of the group, so they came up with new rationalizations for why the cult was important and why the flood didn't happen. And the researchers observed this by becoming participants in this cult. Again, there are ethical problems here, but it is always an interesting method to read about, at least. And that's a very interesting story that perhaps we can talk about more in full a different time. If you want to turn to specific cases of things or specific instances, rather than observing a whole group or some mass of people, you might be interested in a case study. So case studies can be very useful when there's something rare, like a particular brain injury or a particular mental illness that you don't have a large sample size for. You might want to, instead of getting lots of observations from different people, you might get a really rich, detailed, qualitative history of an individual patient or individual person and learn about them. The problem with case studies is that they're very low in external validity. Single cases are not very representative. We want big sample sizes to be able to generalize outside of our sample to bigger populations. So focusing on one person means there are lots of limitations, lots of external validity problems there. But case studies are very useful in the sense that they are going to let us get a much richer history, and they're going to allow us to study rarer cases. Classic examples that we'll talk about more when we get to memory include a patient named HM in the literature who had an operation to stop seizures that ended up keeping him from forming new short-term memory. So, he knew who he was, things about his life, but he couldn't meet new people, and he couldn't remember what he did 5 minutes ago. And we learned a lot about the brain structures that underlie memory from observing this person. But you couldn't do that on purpose, right? You couldn't have a sample of people that you operated on their brain to study in a big group. You needed to wait for that one person to have that happen to them, basically. But Freud used this very heavily, despite the problems that we have with Freud. This tends to get used in clinical literature very frequently, and it gives you a lot richer of a picture of what a person and their circumstances are like. But again, that's very limiting because you can't generalize beyond that. On the opposite side, another type of research we might sometimes call observational would be survey research. This is getting smaller amounts of information from bigger groups of people, often through things like questionnaires. Obviously, this is used outside of science. People use this in market research or political polling, but it's very often used in academic research in social psychology, in political science, in sociology, as well. So survey research, you're generally familiar, I'm assuming, with the way that it might go. You are prompted in some way, you're invited to be part of a survey, or maybe you seek one out for some reason, and you're asked questions, and you try to formulate your own answers. You might be limited in such a way that you're answering multiple choice questions, or maybe you have open-ended questions. There are lots of different ways to do this. And if you use surveys, you can make a lot of interesting sorts of predictions and comparisons. You can look at how things change over time if you measure from the same people over time, or you can look at differences between different groups of people and compare, say, people from different states or different income brackets or whatever it happens to be, to see if they differ on goals or personality or whatever as a researcher you happen to be interested in. It's really important to have a lot of emphasis on your question wording, though. Again, I've mentioned how if you give people some certain field of responses, That's all they can say. What if their answer is different? Or what if they're reading the response options in a way that's different from some other group of people? So you need to really think through the mechanics of how you're actually asking a question and make them very, very clear to avoid things like leading questions or double-barreled questions. A double-barreled question might be something like, why do you think we should spend more on welfare and less on defense? Well, maybe someone doesn't think that entire thing. Maybe they think you should spend more on both instead of less on one and more on the other. So making sure that your question is clear and precise and allows for people to give their natural answer is very important. One other thing you might notice in survey research sometimes is that it's reverse coded. Like there are some questions going one direction and some questions going another. Like, why do you, how important do you think it is that people are equal? Or how important do you think group hierarchies are? Those are oppositely worded types of questions. Agreement on one would indicate the opposite of agreement on another. So that helps weed out people that are just answering straight in a row down questions and helps get rid of some methodological things that are a problem when every question is worded in the same way. Survey research, though, if you want to be able to generalize past even your little sample of people that you're collecting, depends on a few things. Ideally, you would use something called random sampling. And you see in this little graphic I have here, the population, obviously real populations are more than 12 people, but bear with me for a second. If you're randomly sampling from a population of people, then and your sample is big enough and you're doing it in a truly randomized way, then your sample will represent that population. You can see the proportion of people in red, green, and blue roughly or exactly matches the proportion in this population. So if you're doing it in a random manner, then you're going to get a group that is representative of that population. If you use other types of sampling, then it might be less likely that you're going to get a truly perfect sample that actually represents your population. You might engage in something called representative sampling to intentionally make sure that you're getting something that resembles the population, so not relying on random chance and having a quota for the proportion of white and black and Asian and Native American and Hispanic people that you're getting in your survey to make sure it matches some demographics. So these are ways that we might want to sample to make sure that we have something representing the population we're interested in. But unfortunately, much more often, researchers are using something called convenience sampling. So when you read most psychology papers, you'll notice that they say participants in the study were volunteers from a pool of psychology undergraduates that received extra credit for their studies. So that's not a random sampling of anyone. It's a very specific group of people, right? And this convenience sampling causes problems because, it means that our psychology literature is not really the psychology of human beings. It's more or less the psychology of people between 18 and 22 in the United States that are wealthy enough to go to college, right? So there are limitations in generalizability and external validity that come from the way you sample people in your surveys or any study. Like this kind of sampling applies not just to survey research, but to anything, to where you're observing people, to who you're asking questions, to who you're involving in your experiment. So something to be aware of as we talk about different studies. Excuse me. So psychological testing, similar in many ways to survey research, but it's usually longer and more intensive in some ways, and is going to give you a more finer grained test of individual differences, like trying to look at intelligence, for example. You might use achievement tests to look at someone's knowledge, or aptitude tests to look at their potential, like a GRE or an SAT or an ACT. These are, not perfect ways to measure intelligence, obviously, but they might be useful complements to one another. Other things that would fit into this broad category might be tests that screen people for mental illness or disorders, personality tests, measures of cognitive style, measures of things like authoritarianism, or the types of identities that people have. And there's lots of different types of psychological testing that we'll cover over the course of the semester. What I want to wrap up in this video before we move on to talk about experiments is kind of the logic of why we need experiments in a sense. So quick statistics review. I promise we're not going to talk about this stuff too in depth, but I think a kind of baseline level to make sure everyone has is useful. There's a difference between descriptive statistics, which are just describing a population, like the mean and how much variability there is in a given variable, compared to inferential statistics. So you're familiar with these ideas from descriptive statistics, something about their central tendency, like mean and median, or something about how spread out they are, variability, standard deviation, or range. You can use these descriptive statistics to perform inferential statistics. So how much do these means differ from one another? Is it likely that they are truly different in these two groups, or is that something that's due to chance? So inferential statistics help people figure out whether the data they have is representative of the population they're interested in, and whether the mean differences or correlational relationships are due to chance or not. So descriptive tells us what something is like. Inferential tells us if differences or relationships are meaningful and if they represent bigger populations. One really important type of statistical test is called the correlation that you've certainly heard of. You probably use the word correlation once in a while in your everyday speech, but maybe you don't use it in the way that a scientist might use it. So a correlation is a statistic that indicates whether two variables vary together in a systematic way. Correlations go from -1, a perfect negative relationship, to +1, a perfect positive relationship. And if you have a correlation of 0, that means there's no relationship. So if you plot these variables on like a classic sort of X and Y axis here, a correlation of 0 looks something like this at the top left, just a cloud of data. If you get to a correlation of -0.3, you start to see there's something of a negative line you could sort of draw in this data. 0.5, there is a stronger relationship, you can tell. And the closer you get to 1, either -1 or +1, the stronger that relationship looks. Like a correlation of -0.99, it almost starts to look like a perfect line there. But there's still error in all these things. And it's important to remember that correlations in social sciences are often in kind of this 0.3, 0.5 range. They're not perfect relationships that we're observing at all. And I also want to just show you briefly that correlations might not always show us something that's super meaningful, right? This is a website that you can link to that shows something called spurious correlations, correlations that are random and meaningless, essentially. So you can look over time, the number of films Nicolas Cage appeared in the 2000s is very highly correlated with the number of people who drowned by falling in a pool. And the per capita cheese consumption correlates extremely highly, 0.94, with the number of people who died by becoming tangled in their bed sheets. So you can look at these different things and decide what you think, but I believe the real message here is that if you look at enough data, you're going to find things that are related to one another. And it doesn't necessarily mean that that matters and that there's a real relationship there. So in the next video, I'm going to talk about why we might see correlations when there is not really a meaningful relationship, and talk about how experiments help us solve that problem.